So we're going to be looking at what we need to know about the dot product to move forward. So let's go ahead and start with the dot product is only one method for multiplying vectors. There are actually a number of methods for multiplying vectors, and the dot product is only one of them. The dot product is also known as the scalar product because the result of that multiplication process is a scalar rather than a vector. If you think back to multiplication as you've done it in the past, let's say with real numbers, you multiplied two real numbers and you ended up with another real number, or you multiplied two polynomials and you ended up with another polynomial. In this case, we're going to be multiplying two vectors, but we're not going to end up with a vector. We're actually going to end up with a scalar. The next thing we need to know about the dot product is it does have a geometric interpretation, or a way to understand the relationship here. So the dot product can be thought of as vector A dot product with vector B is equal to the magnitude of vector A times the magnitude of vector B times the cosine of the angle between the two vectors. Notice that we have this other representation. The distinction between these two representations being in one of them we have two vertical bars on either side of vector A and vector B, and in the other one we have what looks like absolute value symbols around the two vectors. Both are in standard use, so you do want to be aware of using both of those. And they both mean the magnitude of those vectors. And so we talk about this cosine of the angle between the two vectors. So I have a drawing here with vector A and vector B, and I've labeled the angle we're referring to. There are two angles between the two vectors. There is the one I have labeled, and there is this other angle that goes around the outside. But we're going to require that the angle theta lie between 0 and pi, so that we are always taking the smaller of the two possible angles in this interpretation. Now there is an algebraic representation for the dot product as well, so more along the lines of what you experience when you multiply real numbers. And so what we have here is this says vector A dot product with vector B is equal to the sum I equals 1 to n of AI times BI, where n is the number of components in the vector. So for example, if I have these two vectors A and B, and vector A contains the numbers 1, 2, and 3, and vector B contains the numbers 3, 2, or 1 and 2, both of these vectors have a length of 3. So the dot product would look like this. We'd have the summation I equals 1 to 3 because both of these vectors have 3 components. We would multiply the component of the A vector that's in the first position times the component of the B vector that's in the first position. So that would be 1 times 3. Then I would be 2, so the A component in the second position times the B component in the second position. That's 2 times 1. Then the A component in the third position times the B component in the third position. That would give us 3 times 2. So I would do these multiplications and addition, which in this instance would give me a scalar, or the number 11.